Hi, this is Slow from HyperLend, and this is the code walkthrough of the HyperLend's peer-to-peer lending contract. So the basic features of this contract are that end users can request a loan with very customized parameters, and then other users can fill their own loan request. So the users can select the asset, the collateral token, the amount to be borrowed, the amount to be repaid, the asset, the collateral asset and the amount of the collateral, and the loan duration. And then if the loan can be liquidated when it becomes insolvent, so the price of the collateral drops below a certain threshold. And if the loan can be liquidated, then the borrower also has to select the oracle for asset, collateral, and then liquidation threshold. Other users can then fill the request, and if the loan is not repaid in time or the collateral value drops, it can be liquidated. And then the liquidators earn a portion of the collateral. And if the loan is repaid, a portion of the interest is paid to the protocol. So this is the code. First we have a struct that holds all of the details, and then some events, and then some protocol config. So max oracle price age is to validate that the chainlink price isn't stale, and then max request duration. So the requests aren't active forever, they expire after a week if they are not filled or cancelled. Then the fees and the precision factor used to avoid precision loss when calculating the price. Then we have all the variables that hold the loans, and then the functions. First we set the protocol config, so the protocol fee is 2000 basis points, so 20%, and the liquidator fee is 1%, and the liquidation fee for the protocol is 0.2%, and the request is expire after a week. So the request loan function first decodes the loan from the encoded format, then we do some basic validation, and then we check if the token is ERC20 metadata compliant, because if it isn't, it would cause the problems when calculating the price if the loan is liquidatable. So we just call it should, if the function doesn't exist, it will revert immediately. It won't even revert with the error, but it will just revert. And if the loan is liquidatable, we then check that the decimals match for both oracles, because the quote token must be the same for both asset and collateral. So if both asset and collateral must be in either USD or ETH or Bitcoin, but I think Chainlink only has USD and ETH oracles. And then we just store the details. And for the cancel, it's also we just change the status after some checks. For filling the loan request, first we check that the status is still pending, so the loan wasn't already filled, and if the loan hasn't expired. And then we store the details and check if the loan isn't liquidatable currently, because to prevent somebody from just checking all the loans to find some that could be liquidated immediately, filling them and then liquidating them to earn the liquidation fee. And then we just transfer collateral to the contract and the asset from the lender to the borrower. Then we have the repay function. We just calculate the protocol fee and transfer transfer the value to the lender from borrower to the lender, then returns the collateral and then transfers the fees. So if the token isn't ERC20 standard token, for example, if it's ERC777, it could lead to some denial of service attacks. If for example, borrower, or if the lender would be a contract that would revert on transfers, it would just make the loan impossible to repay. So, but both lender and borrower would lose assets, and this is acceptable risk, and also borrowers are expected to use just standard ERC20 tokens. And then we have liquidate loan. that first checks if the loan is liquidatable and then liquidates it. So when the loan is liquidated, we just do calculations of the fees and then the transfer collateral to the lender, to the liquidator, and to the fee collector. And then when checking if the loan is liquidatable, we just check if the status is active. So because if it's not, the loan can be liquidated. Then we check if the loan is already defaulted, if the timestamp is greater than start plus duration, and if the loan can be liquidated by price, we just pull the latest round data from Chainlink oracles and check if the price is valid and check if the price is not stale, and then normalize the price. So the decimals, because the tokens could have different decimals, and then we just return if the loan value is greater than the collateral times threshold. And then we have some admin functions to update all the protocol settings. So this is it for the peer-to-peer contract. It's a very simple contract, I think. Hi, this is the code walkthrough of the HyperEVM Oracle for HyperLend. So the HyperEVM Oracle is a contract that's used to read the data from the Hyperliquid system Oracle, where the prices are submitted by the Hyperliquid L1 validators and returns it in the Chainlink compatible format, or at least partially Chainlink compatible. So if the price of some asset isn't available as a perp on the Hyperliquid, then we must submit the prices using the keeper bots and then calculated the EMA. So this contract has three parts. First, the aggregator that actually collects all the data from either the system oracle or the keepers, and then it's the asset oracle proxy that exposes the Chainlink compatible interface for a certain token while it's reading all the data from aggregator. So the functions that are available on the asset oracle proxy are the latest answer and the latest round data, and also the description, decimals, and asset. So this is the asset oracle proxy. It's very simple. Contract is just returns the latest answer that it reads from the aggregator or the latest round data that it also reads from the aggregator. And then this is the aggregator. It first has some constants. For example, this is the system oracle proxy. The is at 111. Then it has some constants. For example, max timestamp delay seconds is used to prevent stale price from being submitted by the keepers. And then if the price that's being submitted by the keepers wasn't updated in 20 minutes, it will revert. And then just the EMA window is set to 866 seconds. So we have some details about each asset. First, if it actually exists, then if it's the perp oracle, then we just read the price from the Hyperliquid system oracle, and then the meta index of the that's only used for the perp oracles, because the Hyperliquid system oracle just returns a list of prices, so we need to first get the index using the API, and then we can read it, and then the decimals, and the EMA it's the actual price, but it's only used for the non-perp assets, and then the latest timestamp, which is also used only for the non-perp assets where the keepers must submit the price. So we have the list of meta indexes that map the index to the address of the asset, and then the asset to the asset details, and then just keepers, and then some events. And then the get price, we first check if the asset actually exists, and then if the asset is perp oracle, we return the perp price from the system oracle, and otherwise we return the EMA. So the get perp oracle price just pulls the list of all prices from the system oracle using the get oracle prices, and then gets the price from the array using the meta index, and then the decimals also from the asset details, and then normalizes the price so it's 8 decimals, just like in Chainlink for USD assets. And then it must also remove the also the extra decimals from the system contract that's uh, here are the details. So then we have get update timestamp that just returns the latest timestamp for non-perp assets, and the block timestamp for the perp asset, because the perp asset is updated every time. The perp oracle is updated every 3 seconds by the Hyperliquid L1 validators. Then we have the functions to set the prices or the asset details. So first, if it's not the update, we check if that we aren't overwriting already existing values, and then we just set the details. Again, the toggle keeper just toggles the status of a keeper. And then the submit round data first checks if the price, the timestamp when the keeper submitted the price isn't too low, so the data isn't stale, and if the assets and prices match. So the prices that are submitted must be scaled to 80 decimals first before they are submitted. And then we just loop over it and calculate exponential moving average. And then here is just the calculation. We are using the function from this paper. This is also the same function that Curve Finance uses in their oracles, or at least it's very similar, it's not completely the same. And then we just update the EMA. Thank you.